In today's video, we'll be talking about trigonometric ratio. In short, I just put it as trig ratio. Now, I drew two triangles, which I will explain later why I drew them. We all know that trigonometry is just the study of triangles and the sides and angles that are related to it. So, for the basics, I'll just quickly brush through the basics. Now, whenever you're dealing with trigonometric ratio, you have to take note of the angles. Now, if the triangle you're dealing with is a right angle triangle like this, meaning that there's a right angle in that triangle, then you're going to use your SOHCAHTOA. I will explain, and your Pythagoras theorem. You're going to use your SOHCAHTOA and Pythagoras theorem. Now that is for right angle triangle. Now if the triangle you are given is not a right angle triangle, meaning that it does not have right angle, then you're going to use your cosine rule or your sine rule. For today's video, we're dealing with right angle triangle, so I'm not going to go into the cosine and sine rule for now. We're going to just focus on the SOHCAHTOA and Pythagoras theorem. Now we use the Pythagoras theorem to actually find the sides if two sides are given. So for example, if you have this triangle now, I'm going to tell you the sides that are there. I just want to say explain something. And you have side A, you have side B, and you have side C. Now, if you are given side A and you are given side B, and you are looking for side C, then you are going to use Pythagoras theorem. And what is Pythagoras theorem? Pythagoras theorem is simple. It's just the square of side C is equals to the sum of the square of side A and the square of side B. That is just the simple thing. So if you have to look for side C, you're going to have side C is equals to the square root of the total sum of the square of side A and the square of side B. That is it. Now this is just a simplified version. Now when you're dealing with trig, you need to know that every side has a name. Now in relation to where the angle is. So for example, in this triangle now, we're not looking at 90-degree angle. We're looking at the less than 90-degree angle. That's the acute angle. So you're looking at this angle now. Now let's call this angle theta, and let's call this angle alpha. Now we know that if we are looking at the angle, if we are giving angle theta, we're not giving angle alpha, we're just giving angle theta, then you're going to know that A is going to be adjacent. That means it is under the angle. It is under the angle. Now B is going to be opposite because it is facing the angle, and C is going to be the hypotenuse. That is the longest side. C is always the longest side. So C is the hypotenuse, the longest side. A is the adjacent, the sides under the angle, and B is the opposite, the side that is facing the angle. That is when you are dealing with the angle theta. When you are dealing with the angle alpha, you're not giving theta now, you're giving alpha. Then your A, this is for theta. Now, but when you are giving alpha, your A is going to become the opposite, because A is now the one facing alpha, and your B is going to become the adjacent, because B is one under alpha. Now the longest side will continue to remain C, which is the hypotenuse. Don't mind my handwriting, sorry. So now I've explained what opposite, adjacent, and hypotenuse is. Now let us now put that into Pythagoras theorem. Now in Pythagoras theorem, you'll be given the longest side, which is the hypotenuse, and that hypotenuse is C. So Pythagoras theorem is telling you that the square of the hypotenuse is going to be equal to the sum of the opposite plus the sum of the adjacent. That's Pythagoras theorem. So for you to get your hypotenuse, you have to take the square root of the total sum of the two. Now for you to get your opposite, you have to make opposite the subject to the formula. Meaning that opposite will come to the place of hypotenuse. And if opposite comes to the place of hypotenuse will be going back here. Hope you get. Now if I'm to do that, I'm going to be having minus opposite square, because there's positive sign here. And when you are taking this to this place, it's going to be minus opposite. And when you are moving the hypotenuse to this place, you're going to be having minus hypotenuse square plus adjacent square. Now to remove this square from here, this minus here, you're going to have to take the minus of both sides. What I mean is you're going to be having, because this is approximately minus 1, you're going to be having minus 1 times minus opposite square is equals to minus 1 times minus hypotenuse square plus minus 1 times adjacent square. Now this is just a long journey, because I've said it before, so I have to just follow what I said. Now minus times minus will give you plus, so positive, the opposite is going to be positive, and minus times minus is going to give you positive, so your hypotenuse is going to be positive. Now minus times plus is going to give you minus, so your adjacent is going to be negative. That's why you're having the opposite is equals to the hypotenuse minus the adjacent. The hypotenuse is the longest side, so the longest side is going to subtract the smaller side. That is the logic. So that is that for Pythagoras theorem. Now, one thing in trigonometry is that they are not always dealing with sides alone. They are dealing mostly, majorly with angles. And when you are dealing with the angles, you are going to use, of a right angle triangle actually, you're going to use your SOHCAHTOA. Now, your SOHCAHTOA is very simple. The SO in SOHCAHTOA, it just stands for sine, that is the S, then opposite, then hypotenuse. I'll tell you why it is like this. Now, the CA in your SOHCAHTOA stands for cosine, adjacent, and hypotenuse. And your TOA in your SOHCAHTOA stands for tangent, that's tan, and your opposite and your adjacent. Now let me explain what this means. So it's trying to tell you that for you to get sine theta, that is sine of the angle, you have to divide the opposite by the hypotenuse. The cosine is telling you for you to get the cosine of the angle, that is theta or alpha, you have to use the adjacent over the hypotenuse. And for you to get tangent of the angle, you have to use the opposite over the hypotenuse. That's what the thing just means. That's that for SOHCAHTOA. Now, for me to explain everything which I've said, let me now take you back to this triangle. Now, you see this triangle now. I'm going to redraw this, and I'm going to be using only angle theta. Take note, I said only angle theta. So that is what I'm going to be using. So this is the triangle. Remember, a right angle triangle, and this is angle theta. This is our A, our B, and our C. Now we already know, and we are already sure that C is hypotenuse because that is the longest side. Now we know because of line A, side A is under the angle theta, so that means A is our adjacent, and automatically since B is facing angle theta, B is going to be our opposite. Now if we want to put our SOHCAHTOA into action, we know that definitely sine of theta is equals to what? Opposite over what? Hypotenuse, and our opposite is B, so it's going to be B over what? C. Now the cosine of theta will be equals to adjacent over hypotenuse. Adjacent is our A over what? C. Now I'm not saying adjacent is A because of adjacent starts with A. I'm saying adjacent is A because adjacent is the side under the angle theta. This is the angle theta. Now our tan theta, that is tangent of theta, is what? Adjacent is opposite over adjacent, and opposite is our B, and our adjacent is our A. So take note of that. So this is opposite over adjacent. That is our tan, not hypotenuse. Sorry. That is why it is TOA, opposite over adjacent. That is why it is SO, opposite over hypotenuse. That is why it is CA, adjacent over hypotenuse. Now, in trig, we also have what we're calling reciprocal. Now, reciprocal is 1. Just take note. Reciprocal of anything is 1 over that thing. So if I said, find the reciprocal of x, it's going to be 1 over x. If I say, find the reciprocal of 1 over 2. The reciprocal of 1 over 2 is equals to 2 over 1. Why is it 2 over 1? Because it is going to be, the reciprocal of 1 over 2 is equals to 1 over 1 over 2. 1 over that thing. Now, if you're saying 1 over 1 over 2, what 1 over 1 over 2 means is 1 divided by 1 over 2. Now, based on our normal arithmetic, 1 divided by 1 over 2 is the same thing as 1 times 2 over 1. And now, 1 times 2 is 2. Remember, every whole number is having automatically a denominator of 1. So 1 times 1 is the same thing as 1. That's going to be 2 over 1. And 2 over 1 automatically is giving you 2. So the reciprocal of a fraction 1 over 2 is going to give you 2. Now if I ask, what is the reciprocal of sine theta? The reciprocal of sine theta is 1 over sine theta. And remember, sine theta is b over c. So if you are looking for 1 over b over c, remember from here, we know that the reciprocal of a fraction is turning the fraction upside down. Now 1 over b over c is automatically equals to c over b. So the reciprocal of sine theta is c over b. And now in trig, reciprocal of sine is called cosecant. And in short form is cosec. So automatically cosec means c over b. And remember, c over b is what? Hypotenuse over what? Opposite. That is c over b. That is a cosec. Now cos theta is having a reciprocal of 1 over cos theta. And 1 over cos theta is 1 over what? A over c, which means it is going to give you c over a. Now in trig, cos theta has a reciprocal that is called secant. That is sec. Automatically it means sec is what? C over A, which is hypotenuse over adjacent. Now, tan theta is having a reciprocal of 1 over tan theta, which is equal to 1 over B over A, which is going to give you A over B. In trig, tan theta reciprocal is called cotangent, which is in short called cot. Now, automatically, it means that cot is having a reciprocal of what? A over B, which is what? Adjacent over opposite. Now, just put all these things in your head because we are going to use them to solve questions. But before we're going to solve questions, I would like to take you to what we're calling special angles. So we're going to understand what special angles is. Special angle is just a way to also solve questions without really using our calculator. And those special angles in trig is your 30 degree, your 60 degree, and your 45 degree. Now, if you think that you're going to forget SOHCAHTOA, then try to memorize this triangle. I call it the trig triangle. Now, the O is for opposite, the A is for adjacent, and the H is for hypotenuse. Now, to get sine, just say O opposite divided by the hypotenuse is your sine. Adjacent divided by the hypotenuse is your cos, and opposite divided by your adjacent is your tan. Then you'll not forget your SOHCAHTOA again. So now for special triangles. Now I told you that we have special triangle, special angle of 30 degree, of 45 degree, and of 60 degree. Now I'm going to show you two ways to actually memorize them. Now the first one, how do they get the formula? Now for the 30 degree, we know that the 30 degree is gotten from the 60 degree. Now this is your equivalence triangle. Each angle is 60 degree. Each angle is 60 degree. Now, but remember I told you SOHCAHTOA can only work on right angle triangle. The only way to make this triangle a right angle triangle is if you split it into two. This part will be 90. This part will be 90. Now this 60 have been split into 30, 30. And let me bring out only one triangle out. Now I'm bringing out only this part. This angle is 30 degree. This is 60 degree. And this is your 90. Now, it's an equivalent triangle, meaning that each side is going to be equal. So if I'm making this side 2, this side is going to be 2, and this side is going to be 2. And since I've split it into half, automatically this side is going to be split into 1, 1. So that means you're having 2, 1. We don't know what this side is yet. We're having 2, 1. Now, we are given two sides. We need to find this other side. What do we use? Pythagoras theorem. Remember, the longest side is the hypotenuse. Pythagoras theorem says the hypotenuse square is equals to the opposite square plus the adjacent square. Now, we have two angles here. So you can just pick any of these as your opposites or any of these as adjacent, since we're not using any of the angles yet. So, but we are sure that 2 is our hypotenuse. So we're going to have 2 square is equals to. Now, let's say this one is our opposite. We are using the angle 30 degree. Now we're going to say 1 square plus. Now our adjacent, let's just make it A square. Remember what I tell you, if you want to get your A, you have to make A the subject of the formula, meaning that you have to take A to this side. Now to take A to this side, it's going to turn to minus. I don't follow that long way. So what I will just do is, I'll take 1 square to this side. So you're going to have 2 square minus 1 square is equals to A square. Why did this minus come in? There's a positive here. So when you take your 1 to this side, it becomes what? Negative. When it's crossing the bridge, the currency or the sign is going to change. So you're going to be having 2 square. 2 square is what? 2 times 2, which will give you 4. Minus 1 square is going to give you what? 1 is equals to A square. 4 minus 1 is 3 is equals to A square. Now, we are looking for A. We're not looking for A square. Now, to get A, you have to take the square root of both sides. So the square root of both sides will give you A. Now, remember, square root is the opposite, or should I say, the opposite of 2 of square. So they will cancel each other. So automatically, your A is equals to root 3. So this will become root 3. Now, this is where the angles now come into play. Now, I'm going to draw two different triangles using the angles separately. So the first one is if we are dealing with only the 60 degree. Remember, your sides are still the same. The second one is if we are dealing with only the 30 degree. Your sides are the same. Now, if we are dealing with angle 60, now sine 60 degree is equals to what? Remember, sine is opposite over hypotenuse. 2 is our hypotenuse. Automatically, you put 2 down. Now, the opposite is the one that the side that is facing the angle, which is root 3. So you're going to be having sine 60 is root 3. Now, cos 60 degree. Now, cos 60 degree, cos 60, or when you hear cos, you're talking about adjacent over hypotenuse. Hypotenuse is 2. So you also your adjacent. Adjacent is the side under the what? The angle, which is 1. So when you're dealing with tan of an angle, you're dealing with opposite over adjacent. Put your angle. Now, what is the opposite? The side facing the what angle, which is root 3. That is root 3 Sorry. Now what is the adjacent? Adjacent is the side under the what angle, which is 1. So automatically tan 60 is root 3. Now if you press your calculator is going to give you exactly these values for cos 60, sin 60, and tan 60. Now let's come to 30. And when you are dealing with sine 30 degree, remember opposite over what? Hypotenuse 2. What is the opposite? The side facing the angle 1/2. Cos 30 is what? The adjacent over the hypotenuse. Hypotenuse is 2. What is the adjacent? Now root 3 is the adjacent because of what? Angle 30. So you're going to be having root 3. Now what is tan 30 degree? Now tan 30 is opposite over adjacent. Adjacent here is what? Root 3. Opposite here is 1. Now according to sword, you cannot leave your value like this. So you have to rationalize it. Multiply the numerator and denominator by the value in the denominator. So that's going to be root 3 over what? Root 3. Now when you're doing rationalization and you're having an expression, what I mean is an expression is when you're having root 3 plus 1 or root 3 plus something, there is a sign in between. You're going to multiply by the opposite of that sign. So if you're having something like root 3 plus 1, you're going to multiply numerator and denominator by root 3 minus 1. That is that. But since we're not having any expression, you're just having the normal value. So if you multiply both sides, if you multiply the top and the down, we're going to be having root 3 over. Now root 3 times root 3 will give you 3. Because root 3 times root 3 is root 9. And the square root of 9 is 3. So this is going to give you what? Root 3 over what? 3. That is tan 30. Hope you get. Now we've understood the special angle 60 and 30. Now let's go to 45 degree. Now 45 degrees is trying to tell you that there is definitely going to be an angle of 90 degree. So this is 45 degree. Now this is an isosceles triangle, meaning that two sides are equal. So automatically I'll put this as 1 and 1. Now we don't know this value, but since these two sides are equal, they have to be the same value, which is 1, 1. And this angle is 45 degree. Now we're using this angle. But first, let's get this value. Let's say this value is A. Now we're going to be having what? We're going to use our Pythagoras theorem. Now since this is the longest side, we're going to get our answer straightforward. A square is equals to 1 square plus 1 square. A square is equals to 1 plus 1. A square is equals to 2. Now, if we take the square root of both sides, we're going to have A is equals to square root of 2. Automatically, A is what? Root 2. Now, what is sine 45 degree? Now, sine 45 degree is opposite over what? Hypotenuse. We know that our hypotenuse is root 2. Opposite of the angle is this 1. 1 over root 2. Now, this is the denominator we have to rationalize. So, we're going to be having 1 over root 2 times root 2 over root 2. Automatically, this is going to give us root 2 over 2. Answer. Now, for cos 45 degree, we're going to be having adjacent over what? Hypotenuse. Adjacent is what? The number under the angle, which is 1. So your cos 45 will be the same thing as your sine 45, which is automatically root 2 over 2. Now your tan 45 is equals to opposite 1 over adjacent 1, which will give you 1. That is your tan 45. Now check everything. If you notice here, you're noticing that sine 60 is the same thing as cos 30. So just put it in your head. Cos 60 is the same thing as sine 30. Put it in your head. Cos 45 is similar to sine 45. Put it in your head. Now, the shortcut I want to give you is just a simple table. Now, the table is having 30 degree, 45 degree, and your 60 degree. Then you're having sine, and you're having cos. Now, everything is in fraction, and everything is having over 2. But sine is starting from what? Sine is starting from 1, 2, and 3. That is root 1, root 2, and root 3. This one is what? Inverse. You're going to start from the back. Root 1, root 2, and root 3. Now if you check, it's the same thing.